All right, welcome. Happy Tuesday. We are going to complete 6.1 today. And if you're following along in the book, I'm not doing every single piece of the book. It's not all necessary, I don't think, for what you need. But we're going to start today with inverse tangent. So we did sine, we did cosine, we restricted the domain. And then we were able to lay out the domain and range for the sine and cosine functions to be one-to-one and their inverse functions. We've done their graph. Today we're going to start with tangent. So the big question is, how do we graph y equals tan x? Okay, so if you remember, it feels like it's been a while since we've looked at tangent. So let's look at a few pieces that we know. So y equals tangent x. If you need to use your calculator, you can. Put it in degree mode. That's okay. Tangent of 0 degrees. Tan 0 is, that's right, it's 0. Okay. Then we can move over to 45 degrees. I like pi's, pi over 4. So what is tangent of pi over 4? We could look at a triangle, right? If you want to look at a 45, 45, 90 triangle, that's the smallest triangle I've had. Tangent 45 is 1 over 1. So at 45 degrees, our output is 1. Okay? What about 90 degrees? Do you remember when we did this and we plugged in a lot of things in our calculator? 89, 89.9, 89.99. But if we ever plugged in tangent of 90, what happened? It was undefined. It's that asymptote, okay? Now, as tangent goes from 0 to pi over 4, it's actually going up fairly slow, okay? And then as it approaches 90 degrees, it's going up very fast. It's exponential. It's an exponential growth, okay? And then we went ahead and went past 90 degrees, but I think we also went backwards. We went left. What happens at negative pi over 4 or negative 45 degrees? Well, we're in the fourth quadrant, right? Then tangent has to be negative. Tan 45 is still 1, but we're negative, so we would be at negative 1. Okay, what about negative 90? Negative pi over 2. Okay, it's going to be the same thing. Yep, it's undefined. There's that asymptote at negative 90 degrees. We're going slow, then we're going really fast, approaching 90 degrees and negative 90 degrees. Now the question is, after pi over 2 over here, if there's another point, would it come up, hit here at negative 1, let's see, and then get back to 0, I believe, at pi. Yeah, it is. Okay, and then it would keep going up like this, and it would continue to repeat itself. Yes? Yes, it would. So, if we are restricting a domain, would we need any of this piece over here on the right? Would it be a one-to-one function if we kept this piece right here? Would it be? Our horizontal line test says no. Okay? So I'm going to go ahead and erase. Oops. A little bit of this, probably a little bit more than I wanted to. And that keeps going down. So what we've graphed between negative pi over 2 and pi over 2 is that section, let me go ahead and put it right here, between negative pi over 2 and pi over 2, negative pi over 2 to pi over 2, can we just stick with that interval and it be a one-to-one function? Yes, we can. You may have noticed I started with a bracket, but then I erased it, okay? Because will tangent ever equal negative pi over 2? That answer is no. It will never touch it. So in this case, we need parentheses, not brackets. Because the parentheses says, if we want to go ahead and write it, the x will be greater than negative pi over 2, but less than pi over 2. Okay, there is no equal sign with it. That's what the parentheses means. These two things say the same thing. Okay, so that would be our domain. Okay, so here I'm going to go ahead and put it over here. The domain would simply be negative pi over 2 to pi over 2, and it would be a one-to-one function. Oh, if we're talking about the domain, can we go ahead and talk about the range? What would the range of tangent be? The y values, what does it go up to? What does it go down to? Does it stop here at negative 1 to 1 like sine and cosine did? No. These arrows right here mean what? What do those arrows mean? Yeah, it's going on to infinity. Some people would write all real numbers right here. So I'm going to write all real numbers. Okay? If we want to stick to integral notation, we would put parentheses because it's never equaling infinity, remember? But we're going from negative infinity to positive infinity. Okay? All real numbers, these two things mean the same thing. You probably saw all real numbers a lot in Algebra 2. Okay? That's what this means. These parentheses are just interval notation. And if we're going to stick with interval notation, I just want to keep doing that for the whole thing, okay? All right, so can we graph, since this is a one-to-one function now that we've restricted the domain, can we graph its inverse? Okay, so let's see. Let's do a pink. I like pink. Y equals tan negative 1 of x. So the inverse function for tan, or arctan, would be tan negative 1 of x. So now, how in the world did we do this before? Do you remember? Let's take a moment to think. If there's a couple ways to do it, actually. If we had points, do we have points over here? Could we go ahead and write the coordinates? Yeah, that would be pi over 4, 1. We have a 0, 0. And then back here, this point is negative pi over 4, negative 1. Okay? Could we take each of these points and plot them on the inverse? Remember what we did with them? The x becomes the y and the y becomes the x. We simply switch. So this one, instead of being pi over 4, 1, it would be 1 pi over 4. Okay, 0, 0 is going to stay the same. Right, my x and y's are the same. And then my negative pi over 4, negative 1, will become negative 1, negative pi over 4. Okay, now there's two more very important things on our tangent graph that we need to translate onto our inverse graph. Do you recognize something we haven't talked about? This asymptote there. So technically we're at pi over 2 infinity. So really we would go to infinity and pi over 2. So our infinity is going this way. Then we're going up to pi over 2, correct? So as we're approaching infinity for the x values, this direction, we're approaching pi over 2 here. So it's going to do something infinity to that. But should we connect to this point? Of course we should. connect to this point? Yes. Well, let's go left. Now, I didn't draw this asymptote. It will continue. The asymptote's the whole thing. We don't really see the dotted line, but it definitely goes all the way across at pi over 2. And then this point over here, this negative pi over 2 infinity would become infinity and negative pi over 2. Okay? So as we approach negative infinity, we're going to be approaching this negative pi over 2. Okay, so I'm connecting dots, and then I'm going to make that go that direction. My asymptote goes the whole way. Okay, so it goes from laying down, I don't know, asymptotes going up and down parallel to the y-axis to your asymptotes going parallel to the x-axis. Okay? Well, could you tell me, I'm going to erase some of this so I can write in the corner. Could you tell me what the domain and the range are for the inverse function? So what is the domain? The x values. Well, x values there's arrows here, right? What does that mean? I'm going from negative infinity to positive infinity. Okay, and what is my range? What am I going up to? What am I going down to? Do we have a stopping point now? Yes, we do. Negative pi over 2 to pi over 2. Okay, if you notice, if you remember from last time, the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. We could have told you that before we did it. We could have done just the domain and the range. Maybe I'll just ask you that. If this is the domain and range, what's the domain and range of this inverse function, of its inverse function? Okay? So, again, these two graphs, these two domains and ranges will not change. They need to be in your notes. You need to look at them, because at some point in time, I may just ask you to graph these. Graph y equals tangent x over the interval. That would make it a one-to-one function. What would that interval be? From negative pi over 2 to pi over 2. That's correct. All right. We're moving on. So we've done sine, cosine, and tangent. You have all of those graphs. You have all of their domains. You have all of their ranges. All right. Now we're going to say, can we use this to do a few things? Okay. If I give you, did I go too many pages? Okay, sorry about that. If I ask you y equals sine negative 1 of, let's see, what's a good one to do? The square root of 3 over 2. Actually put it into a problem, okay? And in this case, what in the world does this mean? This also could be written as y equals arc sine square root of 3 over 2. Sometimes they'll put it in parentheses and sometimes they won't. Okay, these two things mean the same thing, remember? Okay, another thing, what it means. What does it mean? It's saying what angle, y, being what angle, what angle's sine is the square root of 3 over 2. Or sine y, you might even want to say a theta, sine theta, equals the square root of 3 over 2. And I'm saying, what angle? What angle's answer is the square root of 3 over 2? Couple things you could do. You could plug it in your calculator. Pull my calculator up over here. And if I'm looking at my calculator, I'm going to look back at the top. So I'm literally just going to put, oh, wait, stop. Let's clear that. I'm going to hit second sign. That's sign -1, okay, of the square root of 3 divided by 2. I'm in degree mode, so I see that's 60 degrees. Is that the answer? Yes, it is. Okay, really, could I have done this a different way? So one way is calculator. I'm going to tell you a little secret. At some point in time, I'm going to say, don't use your calculator. Your book instructions will say, don't use your calculator. So how can we do this without using a calculator? Okay, what do you know about sine? I hope you remember from a long time ago, Algebra 2, even maybe a little bit in geometry, sine is opposite over hypotenuse. So could I draw a right triangle whose opposite is the square root of 3? So I don't know, I'm just going to put a theta here. Whose opposite is the square root of 3, whose hypotenuse is 2. And can you find the missing side length? Using the Pythagorean theorem, I believe I find that to be 1. Does this triangle ring a bell to anybody? Opposite 1 is always 30 degrees. That means this is 60 degrees. Okay? So is my theta or my y equal to 60 degrees? Yes, it is. All right. And that's it. Could I have done that in radians? What if I had put up here, because I didn't give you any stipulations, what your y had to be. Maybe I said it was between 0 and 360 degrees. I would put a bracket here most of the time. Oh, no, they're not going to do that. That's the next section. I'm sorry. I'm jumping ahead. What if it just said between negative pi over 2 and pi over 2? Or it could have done 90 degrees to 90 degrees, negative 90. Okay? If this had been my stipulation, if my problem had really said, are you ready for my squiggle board? If your problem really said y equals sine -1 of the square root of 3 over 2 in the interval of this, find your y. Okay? Would y equals 60 degrees been an appropriate answer? No. And why not? Because my interval is in radians. Okay? If your interval is in radian, guess what answer they want? A radian answer. So instead of 60 degrees, you could simply convert that, right? Or you look at your plate, and your plate simply says that is pi over 3. Right? All right. I think that's about it. We are going to have some problems today. So, your problems for 6.1 as we finish this section will be, okay, let me tell you, it's on page, starts on 269 and goes to 270. We are going to do numbers 1 through 4, 13 and 14, 23 and 24, 47 and 48. That should be 10 problems. I may or may not do a video for tomorrow just to see how you guys are doing with the homework. Please feel free to ask questions. And we will talk to you later. Don't forget to like, I forget what it is, comment, subscribe, something like that to my videos. But please don't subscribe. I don't want any more subscribers. It's okay. Love you all. Bye.